Good afternoon, everyone. Welcome to this special workshop on manufacturing readiness level brought to you by the Georgia Tech Manufacturing Institute, also known as GTMI. My name is Paige Shee, Strategic Partners Officer for GTMI. For those of you who may not be familiar, GTMI is one of 11 interdisciplinary research institutes at Georgia Tech that uniquely focuses on manufacturing research, development, and deployment. We help tackle the grand challenges of today's manufacturers and assist our partners in moving innovations from the lab to the marketplace. GTMI has a wide array of facilities and equipment located on main campus for basic research and nearby on 14th Street for applied research in the Advanced Manufacturing Pilot Facility. GTMI's mission includes education and workforce training, collaborative partnerships with industry, academia, and government, and thought leadership. To ensure a seamless presentation experience today, audience members are muted during the presentation. However, we encourage you to submit any questions for the speaker as they arise using the Q&A panel on your screen. We will address all questions at the end of the lecture. If you take a look in your chat box, you will also see a link to some reference documents that will be mentioned during today's presentation. Today, we're pleased to welcome Tom Lastoskie, who will present an introduction to manufacturing readiness level, when our inventions ready to move from the research lab to manufacturing and industry. Mr. Lastoskie has worked for the federal government in various capacities for more than 48 years. He's been employed at the Air Force Institute of Technology at Wright-Patterson Air Force Base, Ohio since January 2009 as the course director and instructor for SYS 213, Management of the Manufacturing Readiness Process, with over 1,900 students taught to date. Mr. Lastoskie has been an active member of the MRL working group for over 10 years and has been a conference speaker presenter at the DoD Manufacturing Conference for 6 of the last 10 years. Mr. Lastoskie is a liaison member of SAE G23 Manufacturing Management Committee, which published the National Aerospace Standard Manufacturing Management Program. He has also participated in numerous manufacturing readiness level assessments as a subject matter expert since 2009. Mr. Lastoskie graduated from the U.S. Military Academy at West Point with a BS degree in Applied Science and Engineering in 1975. He attended the Army Officer Basic and Maintenance Officer courses at Fort Knox, Kentucky, before being stationed with the 264 Armored Battalion in West Germany. He then returned to the U.S. and obtained a USAF civil service position as a producibility engineer with the Aeronautical Systems Division at Wright-Patterson Air Force Base, Ohio, where he worked in the production, quality, and manufacturing career field in various system program offices for over 27 years. We're very pleased to have Mr. Lastoskie with us today to present on this very important topic that is relevant to all budding and practicing engineers. You may now begin your presentation, Tom.
Thank you, Paige. Hopefully I can meet your expectations with presenting this. Just want to let you know that, and I don't believe you see me on camera, but if you do, I do wear a headset because the microphone is superior, so that's why I've got it on. I also want to let you know that I've got a practical background, if you will. I'm a practitioner. And so I'm really a knuckle dragger type that loves to have grease under my fingernails. So, as I talk through this, I want you to understand that I have literally experienced this in both DoD and with commercial industry. I've been to hundreds of manufacturing operations, in the U.S. and even some overseas. So I've kind of been around the block a few times with this. So having said that, for the overview, I'm going to give you a little bit of an executive overview of what the MRL process is, give you some background, then get into what the MRL assessment process is, and in the vernacular, a lot of people use the term MRA. And then I'll talk about a little bit about requirements, et cetera, associated with these assessments and, national best practices, actually national standards that relate to this. Then I'll get into a little bit about, okay, here's how you apply this process when you're talking about product programs, project or program type stuff. Then I've got some lessons learned, from doing this for a while as far as teaching this subject. And then I've got some frequently asked questions about MRAs that, if you as the audience don't have a lot of questions, then I've already got some built in for you at the end. So it's just as an overview, MRLs were initially developed about 15 years ago. I do have to stress that it was original development led by Department of Defense. So there is a strong military view of this particular practice or process. And the reason is that the DoD led this effort. Since that time, we've had, as you can see in bullet 3, participation by government, industry, and academia. We do have it's beyond the scope, if you want to call it, of just DoD now. It is a national best practice. The MRL desk book and Paige put in the chat DoDMRL.org website. So the MRL desk book, all versions of it are on that website. And then the MRL Working Group hosts an annual workshop. We did not have one. We were supposed to have one in May this year. We did not have it due to the COVID-19 pandemic. But we continue to work with industry and academia to improve the MRL desk book and the process associated with that. And the MRLs are considered a best practice in both industry and government. So what's the goal? Address manufacturing quality risk and issues throughout the product life cycle. So look at it as being a discovery activity, and we do want to identify manufacturing and quality risk. That's what the name of the game is with applying this process. What's the benefits? It ensures that manufacturability, producibility are assessed early in development, provides programs with well-documented roadmap to achieve manufacturing maturity, provides understanding of risk and maturation associated with mitigating those risks. And we're looking at, you can apply this throughout the supply chain, customer base with any product. And it obviously is to identify systemic problems too across really the industrial base. Now, the last one there says MRLs offer competitive advantage. I need to let everybody know that there are major companies in the U.S. such as BAE Systems, Raytheon, Boeing that have taken this process and in effect put it as a part of their internal manufacturing operation procedures and processes, and even command media. So, the important point here is that if we have large companies like that applying this, and I want to say they're not applying it strictly, okay, go do an MRL assessment. They're taking the criteria, methodology, and embedding it within their own command processes or enterprise processes. But having said that, to me, that's a strong indicator that industry sees this as being a process that's advantageous to use. So official website, you've already got this. And just so you know, for purposes of what we're going through today, the MRL desk book obviously is the Bible, if you want to call it that, for this process. The MRL criteria matrix, and just so you know, on that website, there's a 4-page legal-sized document that basically you can print that out and has all the criteria associated with this process. I'm going to talk more about criteria because that's, if you don't understand or have an appreciation for criteria, you ain't going to do this process correctly. So background, how does DoD view manufacturing quality? And again, started with DoD and it's gone beyond that. So anyways, we've got product life cycle and product development. So you're going from concept stage through design to build a product, prototypes, etc., and then into production. And by the way, just to be clear about this, when we're talking about build a product, and even early on when you're talking concept, etc., if you're making one of an item or you're making tens of thousands of an item, this process applies to that. You just need to right size it for your activity. So now, and for those not familiar, DoD has acquisition phases. And so I put this up there because between industry and DoD, there's actually a pretty good correlation as to how people basically develop and build products. So this is just to keep everybody on board that even though this process was developed by DoD, that there's direct applicability to industry. So this one, this chart here is just to highlight that there were problems with DoD programs, and these items here, and I won't talk through them. You've got access to all this information. So to make sure that we don't, get off track and get too deep into the weeds here, these items here were all reasons development of the MRL process. And so one thing I'd like to point out there is that you see the AS9103, AS9102, those are national standards through SAE that talk to key characteristics and then first article inspections. So again, this is all a part of the building block of understanding basically manufacturing operations. About that. Now, Government Accounting Office, they're the watchdogs, if you will, for our government, and they put together reports associated with, basically how the government's doing business. These particular ones here are dealing with DoD and major acquisition programs. So those are like the big dogs in DoD. And we're talking, things like the F-35 program. Those are major acquisition programs, billions of dollars associated with it. So anyways, this chart here, that number one there, one of the things that has, kind of reared its ugly head, if you will, is that GAOs found 60% of total cost growth occurred after programs entered production. Now, if you think about logically how products are developed, designed, and then when you go to build those products, by the time you go into production, you should have stable design and good manufacturing processes, stable processes. And so when you talk about 60% cost growth, that would indicate that you're going into production with configuration is not stable, design is not stable, and many times manufacturing processes that are not stable. So what, the GAO reports that recognize the importance of the MRL process to help mitigate those types of cost growths. So again, that's some background associated with this. Now I'm going to talk through the MRL assessment process, basically what it is. And so key document for that, the MRL desk book. And you can see date 2020. And it is a national best practice. There's 8 chapters there. You can see what they are. For the 2020 version, and this is part of, continuous process improvement for us, that we have added criteria to address manufacturing needs during concept phase. And for concept phase, you're talking MRLs 1 through 4. Then we continue to adjust wording for the MRL definitions to match criteria, metrics, and current policy, if you will, coming out of DoD. Did a complete rewrite of Section 6, applying MRLs in contract language. And I was the stuckee for this one because I can actually spell contracts. Anyways, the intent with this is to make it easier for both industry partners and DoD people to look at what type of requirements need to go into contracts. And I want to be very clear about this. When you're dealing with products and you're talking about supply base, or in case of DoD, contracting with a major defense contractor to build product for us, the whole the basis of anything we do is a contract. What it boils down to, if you don't have proper contract language for industry and or DoD, then you lose going right out of the gate. So I tend to vocalize that because and let me make the point here too. When I talked about Boeing, BAE Systems, Raytheon taking these methodologies and incorporating within their command media and their companies, obviously that's not a contract language type of thing. So you can take this methodology and apply it to your own internal companies or wherever you're at. Use the methodology to make sure you're addressing risk associated with manufacturing quality. So you don't have to have contract language, but if you're dealing with an outside source or anything, then you do have to address the contract piece of it. So the matrix was updated, and pretty much each time that we have a new version of desk book come out, there are updates associated with the matrix or a criteria. 2020 version US MRL Users Guide. This document is a companion document to the matrix, criteria matrix that's included in the desk book. This has a wealth of information associated with things to look for associated with the criteria. And if you look, there are some cells within the criteria matrix that may have, let's say, 2 or 3 sentences that are the criteria. Well, you go into the user's guide and you may find 5, 6 paragraphs worth of information explaining, giving additional information associated with what does that criteria mean. And so the user's guide, and just so you know, the feedback from people that use the user's guide, they say, wow, what a wealth of information. This is great stuff. So in the point here, it's in the 2020 version's in work because the 2020 version of the desk book was released beginning of September. I happen to be the config manager, if you will, for the user's guide, and I'm behind time with getting that done. I would expect it'll be done by the end of next month, but the user's guide always lags because there's a lot of stuff that needs to be changed within that document. So I encourage you to go look at this stuff because if you do not have a good appreciation for the criteria, this will help. The user's guide will help you get on the right track to understanding it better. TRLs, I bring this up because TRLs are a companion activity, technology readiness levels, to MRLs. And so, but TRLs is technology oriented, and as the yellow block there shows, TRLs basically don't touch manufacturing world, if you will. So here's some definitions, and you can see kind of what it means. TRL 5, okay, component breadboard, well, relevant, simulated, high fidelity laboratory, okay. So again, and I need to make the point here too. TRLs are very much not as defined as what MRLs are. And so there is the thought, well, if you're a TRL 3, then it should be MRL 3. Well, the two of them don't really match up to each other real well. They kind of do, but yet there's not a one-to-one correlation. So just be careful when talking about TRLs and MRLs that the two of those, kind of match up, but don't explicitly. So MRLs, manufacturing maturity, manufacturing risk, design complement TRLs. Bottom box there says that draft of the desk book was released 2009, formally published May of 2011. So we're approaching, early next year will be 10 years that the MRL desk book is, prime time. So so here's MRLs 1 through 10. Now you might have noticed that TRLs are 1 through 9, MRLs are 1 through 10. But you can see also that in parentheses on all these is kind of where you're at with product development cycles. Okay, so just be aware. What we're talking about here, and that you've kind of right size yourself. If you are if you're actively in design of a product, then you're to the tune of being more in the MRL 6 realm here. So if you're actively designing it from the aspect of for release to for production purposes type of thing, then you've got to be in the MRL 6 range. Because if you're looking at, we're going to go into design and you're looking at MRL 3, well, you're beyond MRL 3. I'm sorry. So you need to make sure you're at the right place within a product life cycle. So threads, this is just to highlight for everybody that there are 9 MRL threads. Now this is, and you can look at this as being kind of cataloging of the criteria into logical areas. Design activities, well, there are certain criteria that apply to that. So this is putting them into logical in our case, cells associated with this, so that instead of having talking purposes, you have 65 criteria for one of the MRL levels. Instead of having just a list of 65 of them, putting them into these categories here, then you can basically manage it better, or you can get the right people with the right background experience to look at these different things. The other thing I want to mention with this is that you see the term design, cost, and funding. Is manufacturing responsible for design? Are they responsible for costs and funding? And the absolute answer is no, we're not. That's not our job jar to be responsible for that. However, it should be obvious that design activities will impact the ability to make product. Costs and funding, if you need tooling for your production purposes and you don't have funding for that tooling, then guess what? You're going to be in a hurt. So all of these things here have impact on our ability to basically make products. So, and the other thing, just to be very clear about this MRL process is a hardware process. Does not apply to software. Having said that, I want to let you know that as a part of assembly processes of product, you being a manufacturing type, you may embed firmware software into a box, okay? And so for our purposes, that firmware or software is nothing more than another part. And so are we responsible for the software? Does it perform correctly? No, we are not. We are responsible to put the correct version of that software per your technical data packages into that box that we're building. So again, all these things have impact to us. A lot of times it's outside of our responsibility to go make it happen. MRL production environment definitions. This one here is one of these foot stomper types that these are the official definitions that come out of the desk book for what these different environments are. And you're talking a pilot line, okay? Pilot line is MRL 8, which means you're at the end of engineering, manufacturing, development. You're ready tomorrow to start making product on a production line, which is the last bullet. What I want to make sure everybody understands, and why there's a star on this chart, is that everybody that is making products need to use these definitions for accomplishing MRL assessments. And there's probably some in the crowd that may be in the S&T world, science, technology, or R&D, research development, that a pilot line is something entirely different in that environment compared to what's being used here. And so, again, in order to do proper assessments, everybody has to be following these definitions, because if you're not following these definitions, you're going to have a result from an assessment that is, my words, nonsensical, because you're not following these particular definitions. MRL criteria. On the just so you know, these criteria, in that it's on the MRL website, the 4-page document, this is what it looks like. And so basically, all the criteria in the form of a statement is there. I failed to mention, in my apologies, the the MRL user's guide that I mentioned with a lot more detailed information in it, we have taken all of these statements from the criteria matrix and turned them into the form of a question. Because we found that when you're doing assessments, it's easier to go and give a supplier a question, or a set of questions, I should say, and have them answer those questions with objective evidence, sometimes called artifacts, but with objective evidence, do they meet the criteria or not? We found it'd be easier giving that to suppliers to answer questions rather than give them these statements, and then it's like, okay, now what do we do with it? So continuing on, what do MRL threads identify? And you see technology industrial base. I won't read through this stuff, but the 9 threads that I talked about, these 3 slides here, talk to, what they'll do for you. One important piece of information here, alpha, technology and industrial base. This is looking at, when you talk industrial base, you're talking national and sometimes international level. And so the point here is that this is looking at the global view, if you will. The rest of the criteria are looking at, okay, now I have source of supply, we apply these criteria to those situations. And believe me, that it's a confusion factor sometimes on assessments when people try to apply the criteria under alpha to suppliers, and it's like, wait, this doesn't make sense. So just be aware of that. So design, cost and funding, materials, process capability and control, quality management, manufacturing personnel, facilities, and manufacturing management. So what's the goal? Identify project program risk. Start with baselining manufacturing knowledge for that particular product. And what I mean by that is that we have situations where either companies and or programs have never looked at manufacturing risk. And the first time you apply the MRL process, that it's going to take a little more effort to get yourself baselined. Once you're baseline, then as the product moves through the product life cycle, then you've got objective evidence information from your baseline activity, and then you can do delta updates going forward. Excuse me. Okay, assessment should provide insight, okay, contributing factors, and you're really looking for gaps in the MRL maturity. And let me make this statement too. One of the things that I've found to be very interesting is that as companies have been applying this, and some of the big ones like I mentioned already, that as they go and look at their internal processes, they have found some gaps with those processes that don't address some things that need to be addressed. And so that's where, the MRL process will allow that systematic look at this and ensure that you cover everything, and not 90 out of 100 items, you cover all 100 of them. So very powerful tool for that. I already mentioned this, but I'm going to, foot stomp it again. You have to understand the criteria in order to perform a proper assessment. If you don't have an understanding of the criteria, then you're lost from the start. And I need to tell everybody, I have seen some reports that come out from MRL assessments, and if I would have been a part of that assessment, I would have been totally embarrassed because they basically did not perform a good assessment because they didn't understand the criteria. And in reading that report, And by the way, when I say reports like this, a lot of these are going to be sensitive information that you're not going to find it out in the open source type of stuff. Because when you think through, once you do see the criteria, there's a lot of sensitive information. It could be sensitive information for the companies that are involved. And so the information needs to be protected. But I've had the ability to touch some of those, look at some of those. I can tell you that there have been people that performed assessments that, I'm sorry, they had no business performing because they didn't understand the basis of these assessments, which is understand the criteria. So which criteria do I use? Best practice, according to Desk Book now, is that you tailor the criteria to your products. And as an example, MRL 6 has 64 criteria. Your particular product may only need to use 43 out of the 64 criteria because of the product, etc. So the point here is that you want to go and make sure you're looking at the right things for your product, and you're going to need to go through the criteria to look at, okay, some will apply, some may not apply. Important point here, people. If you do not use a criteria and can justify it, that's fine. But don't ever go and take the criteria and change the criteria to suit your needs. Once you do that, you're going to go and have a non-standard assessment, if you will, and you could be taken to task, going forward if you're using your own definitions, your own criteria that don't conform to the Desk Book. Because the Desk Book, again, is national best practice, so use it. So it boils down to criteria, use them, don't use them, never change. All right, so requirements, best practice, and guidance. So, number one there, I already touched on contractual coverage. Again, if you're doing an internal operation for, your own, let's say your own company, then that doesn't apply until such time that, you have a product and you have a supplier and you want, them to provide a product to you. But the other ones I think I've already touched on that. But number 4, though, understanding the functional manufacturing discipline. I have to say that as I've been doing this for more than 10 years, as far as, teaching the subject, that I am astounded sometimes at sometimes the lack of knowledge about the manufacturing discipline, and this is even with people that are in that discipline. So just be aware that not all manufacturing people are created equal in that respect. And the other thing here is how industry makes the hardware that we get. You really need to understand who your partners are, who your suppliers are, and how that product's made. I just find it be astounding sometimes when people go, well, I need, a product XXX, and I need it, 3 months from now. Well, you go and look at how that product's put together, that, you're talking about potentially a 1-year lead time to be able to get that product because of tooling, manufacturing processes, yada, 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 all the stuff that goes into manufacturing. You might be talking a year before you can actually get that product, but we got people who say, yeah, I need it in 3 months, so, provide it in 3 months. And it's like, well, wait a minute, if you want it bad, you're going to get it bad, which means that you may get a product that ain't going to do what you think it's going to do because the right discipline and rigor associated with manufacturing discipline hasn't been applied to it. Industry documents. I bring this up because SAE, National Standards Organization, and even international, The Manufacturing Management Program, AS 6500, that is a basis for manufacturing management. Okay, it is a standard, which means that, yes, you can go and put it on a contract type of thing. They also have a standard for quality management systems, QMS, AS 9100. So those two documents can be used, and I've got slides, going forward. But point is that these are the types of documents that, in effect, drive behavior. And I have to tell you, AS 6500. Paige mentioned I'm a part of that committee, that we are actively working on a AS 6500 alpha version, which is actually out to SAE committee members for polling. So potentially we could have an alpha version of that coming out, probably early next year. So again, the idea is, continuous process improvement associated with this stuff. So enough of that one. But to industry out there, you either have a license for this stuff, or you actually got to go buy it if you don't have a license. So it does cost money to get these standards. So this is just to show how the integration associated with these documents. And I have to say, having been involved with the AS 6500 development, I was pleasantly surprised that our committee, and you can see it overlaps with 5 other committees, if you will. Each committee has a different designator. But those 5 committees, there were actually representatives from those 5 committees on our committee, so that to ensure standardization, that we're not saying something, if you will, from the AS65 perspective that is different from the other documents. So there is a real effort to make sure that all these standards play nice with each other. So AS6500, how it's organized: manufacturing planning, design analysis for manufacturing, and then manufacturing operations management. Those 3 buckets, if you will. But over all of those is manufacturing risk identification. Okay, and so the whole thing is based on identify if you have risk and then basically mitigate those. The requirements in AS 6500, this is just to highlight this Mill Handbook 896A. Yes, it is a mill document, but basically industry people that have looked at that document says, hey, that's a good document because it helps with basically formulating requirements of AS 6500 and how to put those in appropriate contract language, if you will. And so this is just showing that depending on what phase you're in, product lifecycle perspective, as to whether the different requirements within the document apply or they don't apply. So darn good document, people. So if you're ever going to use AS 6500 and put it into contracts, use Mill Handbook 896 Alpha to help you with that process. By the way, I've got industry buddies that say good document, use it. So it's not Tom saying this, it's industry saying that it's good. So this is just an example that within AS 6500, paragraph 6.3.2, manufacturing readiness level assessments. And so having AS 6500 as a requirement buys into, you will do MRL assessments. And I'll be headed toward showing you, how to do that, how to perform assessments. Get a drink, sorry. So don't forget quality. quality management system. And you can see AS9100 I mentioned, but there's ISO 9001, there's automotive. There are numerous quality standards that are out there, and it depends on what your product is that you're building as far as what QMS you'll use. Having said that, AS6500 is the only manufacturing management standard in existence at this point. So, AS6500 applies to everything. QMSs, if you don't have one in like it says here, aerospace, AS9100 is very prevalent. Automotive, uses different one, and then ISO is international standard, quality standard, and so that's used by many other people in the world. So this just to show, and this is in the MRL desk book, that left side you see the MRL threads, see the AS6500 requirement, and then also where you find it within AS9100. So this is just to show that the MRL process is very much in line with these national standards that I mentioned. And this chart just shows how all this stuff plays together. All right, now, gonna, overview of that. Now I'm gonna talk through, okay, how do you go and apply the MRL process to a project or program? And this is looking at it from the, top level, if you will, a programmatic level, project level, not from a individual item or supplier in that program. So we need to know the following information: which elements have reached target MRL value, and this is where, okay, where are you at in a product life cycle? And the target value would be, okay, if you're at the end of engineering, manufacturing, development, you're ready to go and make production product, then that would be MRL 8. So that'd be your target value. Understand potential impact if the element fails to mature. And so what this is talking to is that if you are not, or if you're not able to meet the criteria, that means, okay, there's going to be some risk associated with that. Then you're going to have to go and look at, okay, how much risk do we have? And so that's the second piece of the puzzle. Identification that you have a risk. Second, then, is quantification of that risk. So this is just showing that, the overall project program level. I'm going to step through how you would look at an end item product, and then basically identify, okay, where do we have potential manufacturing risk? I'm going to step through this process, a version of the process. This is not the answer, okay? This is kind of Tom's view of how to go and look at it in identification of potential risk areas. Because what it boils down to, if you have a product that has 100 components to it, you're not going to go use this process on all 100 components. You're going to go and do this kind of, if you want to call it tabletop assessment, to look at, okay, out of these 100 components, we have 10 of them, let's say, that we need to pay attention to because there could be some risk there. Those are the ones you're focusing on. I'm going to show you how to kind of look through that. So we need to understand product life cycle. You see the bullet there says contractor, critical suppliers, lower tier suppliers. Well, if we're earlier on in the process, and let's say, that you're just starting design effort, you're back, MRL 5, MRL 6 time frame. Well, you might not have a contractor for that item. Critical suppliers, lower tier suppliers, those would not even be, in anybody's view yet, because until you have a design, you're not going to go out and look at who's going to be able to supply the parts that you need, because if you don't have design, then what's the point? So anyways, step through, develop lists of candidates, rank order lists for importance. And why this is that pretty much that if you have potential risk in manufacturing operation, you need to go see that operation, okay? And it says hands-on, eyes-on. And I understand, today, today's world, it's very difficult because, we're doing a lot of stuff virtually. But point is that when you're talking about manufacturing operations, it's kind of like you got to see what's going on. If you don't see it, then you don't really understand it. Over the years, I've been in places that, supposedly, they know manufacturing. And I go into some of these places and it's like they're clueless, as far as, manufacturing operations, as far as stability, et cetera, et cetera. So again, it's like you do need to see what's going on in a shop floor. And I call it jungle kingdom, because until you've been on a shop floor, see what's going on, you really don't understand what's going on. So going forward, need to understand relationships. And this one here obviously shows military acquisition organization in the middle, contracting with the prime. Those kind of relationships apply, everywhere within industry too. So on the left side, you see tier 1 supplier, tier 2, tier 3 suppliers. And this is where I just make the point that once you get below tier 1 suppliers, and contractual arrangements can get real muddy real quick. So just be aware of, what we're dealing with from a, big picture perspective. Need to understand how large contractors organize. And I've got, again, military example, that predominantly I, deal with military people, but this is just bringing up the point that anytime you're dealing with a large organization, that need to understand the contractual arrangement. That's what the right side of this is, the contractual arrangement, if you will. And you can actually put, suppliers instead of the large contractor down in these blocks too, that when you get into a company or, an enterprise, that those contractual arrangements you have may not apply to internal manufacturing operations, because those dotted lines are showing, well, they're at the same level. So do those contract requirements flow to these other organizations? Well, they're all at the same level. And so the point here is that it needs to go through the executive suite, if you will, to say, okay, we're going to do things this way from an enterprise perspective, and it has to come out of there. Now, I had the rhetorical question: where does quality belong? And spoiler alert here, that the quality standards, AS9100, ISO. Those quality standards say quality is to report to that executive suite that's at the top. And I've been in places that the quality program reports to operations. And if that, if you go into a place and quality reports to operations, I would suggest that you have a problem. Because operations, what's their goal in life? Ship product. And so end of quarter, end of year, end of month type of thing, that if there are some quality issues, they're going to ship product because that's how they get measured. So quality needs to be at a higher level, the executive suite level there. And like I said, the standards all require that. but there's a lot of people that don't know that the requirement is at that level. Then we need to understand types of manufacturing operations. So you see, go on the bottom line there, higher cost, lower cost. Left side, lower volume, higher volume. Well, as you move up the ladder there, you're talking about, I'll call it more sophisticated operations. If you're making integrated circuits, well, you're going to be up on the upper right on that schedule. If you are making satellites for the military, you're probably on the lower left corner there. So the point is that those are different from a manufacturing perspective, and that the idea that, okay, do process improvements, do capability assessment. Their term CPK for capability of manufacturing processes. Well, if you make 5 of something, then you can't determine a CPK because you have to have a statistically relevant number of samples in order to come up with something like that. So associated with this is, if you're in the lower left quadrant there, that some of the information that is called out by the criteria in the MRL matrix may not be available based on volume of product being. And plus, the other thing, and I want to make sure you understand this, the lower left quadrant, it has a lot of touch labor, manual operations. Upper right could have a lot more of really hands-off from an operator perspective. And so, just like you mentioned ICs, those are basically, humans don't touch that stuff. But they're making zillions of those things, okay? So you can set up the manufacturing line to accommodate that. But what it boils down to, much different for when you're talking about, okay, what about the data to support? Do you have maturity from manufacturing perspective? And then need to understand the size of U.S. manufacturing operations. And this is for DoD products, but I bring this up to people because when you look at the products being made for our warfighters, that you look at 3/4 of the supply chain is small businesses. And so when we're talking about some of these techniques, criteria, etc., then small companies don't have as much, generally, capability as what big guys do with some of this. So that's where, and by the way, DoD, because volume-wise tends to be, not much. I mentioned the F-35 program. There's going to be several thousand of those aircraft being made, but when you look at it from an industry perspective, that's small peanuts volume perspective. So just be aware of that. Those things come into play. And then really last thing is, need to understand how things come together. You have a program and there's going to be, 100 items come together. Then, okay, where do they come from? Who's doing what to whom? How does all that flow? And, what does it mean to manufacturing? So now let's get our hands dirty, talk through the other stuff to understand that. But now, as far as identification of potential risk areas, critical technologies, other significant areas, work breakdown structure, bill of material, and then 9 filtering questions. So it's kind of like, okay, step by step through this. CT, they're also known as CTEs, critical technology elements. But basically, if a TRA was performed and there are some CTs identified, then we would look at those, we being manufacturing again, would look at those CTs and look at it as to what's the impact to us. And I've seen situations where there could be, a handful of CTs called out as a part of, I should say, as a result of doing a TRA. And I would look at them, at those 5 CTs, manufacturing perspective, and I would say, okay, these 4, no impact to me. The 5th one, this one could. So therefore, that 5th one would go on to, my list for looking at that in more detail. Work breakdown structure in this aircraft example, but basically, everything that makes, that comes into that end item, it's all listed there. In this case here, I got these yellow ones that I'm looking at going, okay, antenna, same cast of characters, design-wise, we've seen that before. Receiver, same thing, transmitter, look at that and go, ain't never seen one of them things before. So basically, from a manufacturing perspective, new capability, and, we're going to have to form some gee whiz stuff to go make that thing. So that one there then would go on my list of potential risk areas as risk area, because I don't know, have no information on that one. And then key characteristics on a bomb, and key characteristics are no kidding, they're important to the design. And this right here is an example, notional example, it doesn't have any dimensions on it because this is real world. But you see steps and gaps associated with structure coming together. And basically it's the outer mold line for a stealth aircraft. But, and just so you know, I've dealt with this stuff in the past. It's on the F-22 program. We dealt with this back in the 80s and 90s. But anyways, I look at it, and this KC means absolutely you've got to hold that tolerance. Okay, no kidding. And so I'm looking at it and going, wait a minute. The tolerance they're asking me to hold is 2 times better than what I'm currently capable of holding. So knowing capabilities, knowing they're asking me to do, Tom's words, the impossible, that this is going to be a risk area, okay? And spoiler alert, F-35 has had issues in this area. And then there's 9 filtering questions from the desk book. And kind of just step through these. I'm not going to read all of them, but you see materials, cost, design. Just point on design here. It says novel design. Novel means ain't never seen one of those before. So again, processes. I've been involved in programs over the years that manufacturing capabilities weren't what they needed to be in order to, build production product. Quality, schedule, okay. And in today's world, I was talking about lead times that, there are some materials that, okay, I need them, next month. And it's like, well, you'll be lucky to have them next year because lead times associated with facilities. Obviously, do you have the capacity to be able to build the number of product need to be made? And supply chain, or supply base, and then the industrial base. And this one here talks about critical item manufactured by a sole or foreign source. I've had distinct pleasure of dealing with some foreign sources, and I can tell you, if you've ever dealt with basically US-based companies as sources, and then you need to deal with a foreign source, 3 or 4 times harder to deal with that source, typically. Not all the time, but typically. So once we applied all these things, okay, we're going to have a list of candidates. We need to rank order list for importance, and this is where you take, people that with experience to look at this stuff and go, okay, this one is more important than this one, that type of thing. And then, we need to get biggest bang for the buck. And what it boils down to is that, and I made the statement, you can't go look at everything. You want to go look at the ones that are important. And this is a way of, helping to filter that to get that important. And you still need to get objective evidence and data, okay? And so this next one, and this is showing that, okay, we've identified 8 here, cut line for amount of funding available, because in order to go look at these top 5, you're talking about travel, number of people there, spending, typically total of a day and a half to 2 days type thing. So when you go and add all that up, then there's going to be a certain amount that's going to cost to do that, and you're going to have a finite amount of funding to go make this happen. If you can make it happen. I've seen situations where they've got 0 funding. It's like, oh, that's cool. How are they going to do this? And it's hard, people. So anyways, we've gone through the left half of this, the 4 blocks. Then you conduct the assessment. And let me back up 1 second. When I say conduct the assessment, those top 5 are the ones we're going to go look at. So now we're going to conduct the assessment, and then, a result of those assessments, then you're going to assess what the risk is. So here's large programs, conceptual view of how, this stuff plays together. For this red X here, we determine we're not going to go look at that one. These other 3, yeah, we need to go look at it. That's kind of the way to look at it. And projects, S&T projects on the left, ManTech, manufacturing technology product, a DoD activity. So conceptually, again, this is how that kind of looks. This slide here shows what an MRL assessment approach looks like. Desk book. Again, just kind of how you go through the steps of this. Now, conducting the assessment. So we're upper right corner of this one, right? And so how do we proceed? Obviously a targeted MRL, so you need to know where you're at in the product lifecycle. Use 1 or 2 levels below the target to address shortages to the target. So if your target is an MRL 6, then you would generally look at MRL 5, MRL 4, because what it boils down to is that nobody is ever at where they need to be. And so target of MRL 6, there's always going to be a few items that ain't going to be where they need to be. So that's why you go 1 or 2 levels below to address those. And then I tell people, okay, the MRL team lead, look 1 level above the target. In our case, we're talking MRL 6, that the MRL team lead looks at MRL 7 from a programmatic and by that's a program level, that, if you need to be at MRL 7 in 6 months, that depending on what you're looking at today, may be impossible to make in 6 months. So that's just to, again, address risk associated with this. And that's not part of formal assessments. And experience is crucial. And I have to tell you, I have seen a couple of reports by people that did an assessment, and when you look at experience of team members, it's pretty much zero as far as applying this process. And basically their assessment and report was just garbage. So what do we look at? Pay attention to details. All the criteria that's pertinent, you've right-sized it. So you have the 43 or whatever number that was instead of 65. Make sure you cover all of them. Has all objective data been verified? Important point here, people, when you're talking about objective data. And that's where talk about going and doing a hands-on, eyes-on assessment. A lot of this objective data, objective evidence, is going to be within the four walls of that facility that you're visiting and can only be looked at there. A lot of that data will not be released outside those four walls. And so that's one of the pieces of this that when we talk about objective data, and if you think about it, let's say that you want to see the process capability data for their laser shock peening operation. Well, you think that they're going to release any of that data outside the four walls? And typically no, because that's company sensitive information. And, if you're fortunate, they'll, let you look at it, but you ain't taking a copy of it outside those four walls. So just be aware of that, because we always talk about objective data, objective evidence, but not always do you get, you're going to have to see it there, or you're not going to get it sent to you, if you will. The MRL team done an in-depth review of the critical processes, and this is where I mentioned the laser shock peening process, that when the team's on site, got to go from beginning to the end, and it could be 3-hour operation. You got to go through every step of that process, because if it's a critical process, you need to observe what's going on. Are the workers following the work instructions? Is proper data being collected, et cetera, et cetera. Because if that's not being done, then you don't have a stable process. And if it's critical, that means chances are you're going to get product coming out of that factory that doesn't meet the need. So I already mentioned work instructions. Shop floor tribal knowledge prevalent. This is, and I mentioned it before about you need to see what's going on the shop floor itself. And tribal knowledge is something, and I've seen it happen where an individual knows the correct way to do something and keeps it very close to heart, because if somebody else knows that, then there's possibility that he could, when there's downsizing, that he could lose his job type of thing, he or she. So tribal knowledge is, basically, what people know about doing these operations. And like I said, if you're in a situation where these operations are very touch labor sensitive, then you'll see more of that there than you will in a more automated factory environment. FAIs, PCAs, first article inspections, I mentioned that earlier, and then PCAs are physical configuration audits. So those are verifying basically that products being built to print. And have manufacturing quality contract requirements been met? And if you have contract requirements, then that's a part of paying attention to that. I already mentioned must see, verify, objective evidence, documentation, conduct private meeting from your team, if you will, that, once you've gone and looked at everything, get together and, what do you see, and, pluses, minuses type thing. Excuse me. So, antigen manufacturing risk. MRLs do not meet the readiness level. We'll have MMPs created, manufacturing maturation plans. That's the formal term that's within the desk book. Basically, it's risk mitigation plans is what that is. Right? So paragraph 5.2 talks to that. And if a report's being put together, and not always does that happen, but if required to put a report together by your management, I always say make MMPs an attachment or addendum. If you put in a report, I should back up. MMPs, attachment or addendum, because they are live documents. Okay, and so if you need to make changes to the MMPs, then if you put it in the report, then you'd be changing report all the time. Bottom line. All right, so lessons learned. MRL deployment challenges, unrealistic expectations. Okay, MRLs do not solve problems. They assist in identifying risk and issues. Certain products programs will have delays when manufacturing maturity is not achieving target MRL. And I can understand that as a concern, because in order to do things right, it could delay, basically making a product. Inconsistent understanding interpretation of how to apply MRLs. This one here, I have to say, is huge. I have seen, gross misunderstanding, gross misinterpretation how we do this stuff. So I'm just giving you a flavor of this. Until you actually go out and perform these assessments, not an easy task, people. It takes some sweat equity on your part to understand this stuff. Workforce inadequately trained to effectively and efficiently deploy the MRL process. That applies across the board, industry and government side of the puzzle. And the perceived cost benefit of using MRL. And this one here is, people say, well, tell me what benefit is, how many dollars am I going to save? And that is absolutely a tough thing to quantify. Because, first thing is, okay, as you go to apply this, then it could be a couple, 3 years sometimes before you get any data out of it. And then what's the relevance of that data to if you would have done it the wrong way, if you will. So that's a tough one. Now, having said that, I do believe, based on some, very large companies within the U.S. taking this methodology and using it in their internal operations, they are seeing a benefit associated with this. Because companies like that would not apply this if they don't see a benefit. And so they are seeing a benefit, but again, there's no hard and fast documentation. Now, I can say that one of my Boeing contacts told me that they've saved millions of dollars with applying, this methodology in their internal operations. But I have to tell you, I read Aviation Week religiously, and the last couple of months, there's been some scathing articles in there about quality shortfalls associated with Boeing. So maybe manufacturing's been okay, but their quality is not where it needs to be. So feedback, industry. And I'm sorry, I should have done a better job with having this stuff all there at the same time. The MRL process viewed as value added by, manufacturing guys and gals, us knuckle draggers. Identifying risks, mitigating those risks can save money. The third one there, understanding how to properly apply the MRL process takes time and effort. And across the board, people that are serious about doing this, that is an absolutely true statement. Then for DoD, proper training explanation, that kind of follows industry. People within DoD are, seeing that, hey, this, if you apply a process correctly, you can get, good results from it. But comes down, you need to be versed in manufacturing quality, functional area in order to apply it correctly. And that's easier said than done. The lessons learned, process more effective if basically everybody doing it fully engaged. Got to have good communication. At on-site assessments, if there's any disagreements, sit down and go through the matrix, use a user's guide, and basically come to agreement as to what the criteria mean. Assessment report and MMPs take much longer to complete than you might expect. Because MMP, you're talking about a lot of information associated with mitigating the risk associated with that. And subject matter expertise, you really do need some of that in order to do this correctly. Just, I put in front of people all the time, don't be surprised when inappropriate requirements are put into contracts. I have been privy to some stuff that government has given to some of our large contractors. I said, I've got, buddies in industry, they send me something, go, hey, check this out. I'm appalled at poor requirement that was given to that company. So again, you need to understand the process and then need to understand how to put, the requirements for, the MRL process onto the contract. Objective evidence artifacts to satisfy criteria can be difficult to assess. And that brings home the point that, one criteria, within the matrix, there's criteria about, quality plan. And basically that's for the product that's being made. Okay, so a quality plan's given to me, and so it's got title quality plan. How good is that plan? Well, if you can't spell quality and you're given that document and you go and flip through it, does it meet the need or not? I'm sorry to say, you don't know. So that's where the difficult to assess means that you've got to have the experience and background, be able to look at that document and say, hey, this is a great document, or this is a piece of garbage, and, it doesn't meet the need. So difficult. Transitions from S&T, science technology, to production, to sustainment. I need to make the point, sustainment here, we're talking about MRO activities, maintenance, repair, and overhaul for industry, that those are all manufacturing operations too. So, but the point is that transitioning from one to another, from product development to product design to product build, and then sustainment of that, those are different communities of people. And so applying this process the same, if you will, among all those people is difficult because they're basically 4 different stovepipes of people. Big thing, it's not about the numbers, about the risk. So, frequently asked questions. So I put some of these together to kind of talk through maybe a little bit, and maybe some things that you're curious about. So what happens if MRL is not achieved by the time it's required? Well, what that means is that you've identified it. That's where the MMPs come into play. And so, you need to be diligent about executing those MMPs to mitigate risk. And so if you've done the assessment and you need to be, whole, if you will, 3 months from now, then you got to be diligent about executing the MMP to make sure you're good 3 months from now. So if you're not where you need to be, that would indicate there's still some risk there. And so that's where you got to keep, management apprised of, okay, we're supposed to have this done, today, let's say, and we're not there, but we'll have it done, 3 weeks from now. So what's the risk? Well, if you show good progress, then that would be considered low risk and, continue on with your activities then. Are MRAs a pass or fail audit? And then the answer is adamantly no. Okay, again, it's about the risk. So, and I've seen people, take this and say, okay, we need to be at the end of EMD, getting ready to build product or production product, we got to be an 8. And people will lose sight of the fact that, hey, it's the number, it's not the risk. And I've had some major companies do that to me. And I try to talk to them about the risk piece of it, and it's like, hey, we got to beat the number. Well, it ain't about the number, people. So target is important because that identifies what criteria are going to be used, and then what's the risk. And then you deal with the risk at that point. And by the way, and I tell people this all the time, if people are asking you for a number, then they're asking you the wrong question. You need to go and be adamant to them about that's the target value, then here's the risk that we're working to meet that target value. Read the desk book, How You Properly Apply This Process. This is where, today I went through a little bit of looking at this and how you kind of step through this. And by the way, what I gave you today is not the answer. Okay, this is just to give you an idea about what this is about. The MRL process, what it's about. So it takes time to go and really right size this stuff for what your needs. Got to apply some critical thinking to this stuff. It ain't a checklist. Somebody says, oh, I'll use a checklist. Baloney, this is not a checklist. You got to put some thought to this stuff. How do I adjudicate customer requirements and individual company command media? It all boils down to sometimes you run situations where companies say, well, we've got this manufacturing process is codified for our company. Okay, that's fine. Then that process needs to still satisfy criteria in the desk book at the appropriate time in the product life cycle. So you still have to address that. How early should you apply process? Earlier the better. And you might have noticed I talked about 2020 desk book just released, that there were additional criteria added to the MRL's 1 to 4 time frame, which is concept development. So choosing a material solution, that there are more criteria there to address. Here's things you need to be looking at that early in the product development lifecycle. What constitutes an appropriate objective evidence to satisfy criteria? Obviously, you want to verify criteria is met, right? But the MRL User's Guide that I mentioned before has information about identifying the type of objective evidence. So this is where, if you have a question about, okay, what objective evidence, to meet this criteria, User's Guide is a place to go because it will tell you explicitly, here's the types of documentation you want to look at in order to verify the objective evidence meets the need. How you get across management about the MRL process, not about numbers, about the risk. Numbers don't identify risk, okay? But this one here is a tough one, people. Very tough. I've actually dealt with, I'm sorry, my bad. I've actually dealt with some, executive level people that, I go and tell them that, and it's like, just give me the number. I don't want to hear about, details. Just give me the number. So that's a tough one. But I can say I'm old enough now that I just tell them, that's the wrong question. You need to be asking about the risk. So I know a lot of people are not at the end of their careers to be able to tell the boss to think different. Do we need to follow the order criteria, thread A, B, C, etc.? And no, you do not have to follow that. I mentioned thread alpha is a more strategic look. Okay, the other threads are a tactical level or a supplier, level type thing, even contractor supplier level. So you don't need to follow the order that way. In fact, we've been finding that the order for earlier development activities, MRLs 1 through 6, actually it's better to do a different order than alpha through India than to go and later on then you have a different makeup, if you will, of order for those threads. So it's what makes sense for your project or program. And again, that one there comes with experience. And I bring up about MRO activities because there are people in the business that think, okay, if you're not doing new production, new development, new production, then you aren't doing manufacturing. And actually, MRO activities that the MRO process absolutely applies. You just have to go and critically think about the order associated with that. And the desk book does have a little bit of info on that one. So it looks like I'm done.
Thank you, Tom, for a very informative presentation. This is important for our participants who are already or will be working with government or industry. And I think our students and researchers who have some basic awareness of manufacturing readiness level may be a step ahead as they prepare to enter the workforce or prepare to ready new inventions for the marketplace. So at this time, I thank you for running through the frequently asked questions. But at this time, I'd encourage our audience members who have any additional questions to go ahead and submit those using the Q&A panel on your screen. And there is a slight delay on our end until we can see the question you've typed, so we will allow a minute or two for our audience members to go ahead and enter any questions they have.
Yeah, and Paige, just so you know, I put with the slide deck, I've got this here, what do you need to do to meet MRL 4 criteria? And this is just, excuse me, this is to show number 1 there, that's the criteria. And then the underlined items there would be the objective evidence associated with that. And that's the stuff that's included within the users. So I've got that quantified here because I have another activity that I do, Miami of Ohio University, that they use this material here. So I just wanted to highlight that for everybody, that user's guide is not an empty document.
Great. Thank you very much.
Sure.
It looks like we do have one question so far from Jane. She asks, if a company has produced many of a product type, say batteries or circuit cards, but has not yet made the specific one or made very few in review as part of an MRA, does the MRL assessment result in a low score, high risk, or is credit given for proven manufacturing experience with similar products?
Great question. What it boils down to is you need to look at are there common processes being used across the two, and I'll call the old line the new line. Let's use that terminology. So if there's common processes and they can show that they've got those processes under control, then absolutely you can use that as credit going forward. The big thing is, and I want to make the sure that everybody understands that just because it's similar to something else does not make it the same as the old one. I have seen too many situations where people say, "Oh yeah, similar to whatever," and it's like, yeah, we don't have to pay attention to that, and then you have a train wreck because the 5 processes out of 200 processes that are different, they're not mature in that they will eat or they can eat your lunch. So that's the part of it that, and having said that, part of this is that, okay, you need to understand the product, and just like, to your point with batteries, okay, how much is the new battery, how much commonality is there between that and the old battery? And so that part of it, you need to really kind of dig in and look at it and, and kind of put together, if you will, a spreadsheet that, okay, these 50 processes are the same, yada, yada, good on that. These 10 are, slightly different, and these 5 are like absolutely new. And so you're going to go and look at those ones that are, not shown to be under control, or you might have to develop some capability from manufacturing capability perspective, that those are the ones you'd address then. So don't address everything, just the different ones. But you got to be diligent about it. Don't ever believe that, oh yeah, all is good. I've heard that over the years too, and it's like, no, everything ain't good, because they haven't actually looked at all those types of details. Does that help?
Thank you, Tom. If we have any other if there are any other questions among audience members, please go ahead and enter those on your Q&A panel. We'll allow a couple more minutes here for additional questions to come in. And I would again refer everyone to also the event chat, where there is a URL to reference documents that Tom mentioned today. I would encourage everyone to go ahead and take a look at that website, which is www.dodmrl.org. And you can reference some very important documents that Tom reviewed today.
But you won't find any of the AS standards on there. Those things are close held by SAE.
Okay, thank you for that. It looks like there's an additional question from Bob. How do you see this as applying to the software firmware part of manufactured IoT devices?
The only way that it would apply is that it's just another part from a manufacturing perspective. So what it boils down to is, when you look at materials, availability of materials, with that being another part, that if you're assembling the item in firmware or software as a part of the build of that item, then you either have it or you don't have it. That pretty much is the end of what manufacturing's responsibility is for firmware or software.
Okay, thank you. Are there any other questions out there? Well, Tom, I think that those are the questions I'm seeing at this time, and I think you covered a lot of questions people may have with your FAQs. So thank you so much for your preparation and presentation today. I think it was very informative and very relevant to our audience. So we thank our audience members for joining us today. Hopefully you found this informative and helpful to you. And take a look at the GTMI, Georgia Tech Manufacturing Institute website for additional upcoming events and lectures. Thank you, everyone. Have a great afternoon.